give me a couple of minutes. So
Sure.
before I hand over it to you, I'll probably have to share the screen. The first thing that I wanted to let you all know is for those who do not, let me share my screen quickly. Okay. So for those who do not have access to Testoper Teams, you can send your email address in the chat box. We will be able to add you into the collaboration platform that we use, right? I know that Teams do not have Microsoft do not have a feature in Teams where you can log in both your Office account and the Testoper account. They are probably working on that feature. We are expecting it to come soon. So the way, if you are joining from your Office laptop, the way you have to do is you have to log out from your Office Teams and then log in into the credential that you would create for Testoper Teams, and you can join. Or you can directly join from your Office stuff. But the difference is, if you join from the Testoper ID, you would be able to see the channels that I'm seeing in the left. So the top one is the management. You wouldn't see. This is for the volunteers, unless you want to become a volunteer, you wanted to organize the program, speak and things like that. You won't see this, but if you join our volunteer team, you will see this. We have more than 25 volunteers who help us in different areas within our community. If you are not in the volunteer team, then you would actually see the one that I'm showing you in the left, Testoper community, and you can see a lot of channels there. So we constantly put the jobs, and we constantly, there's a mentor-mentee program. We are running few hackathon projects that we are doing. In fact, we are implementing a Testoper application that can help the attendees to benefit a lot, right? So those kind of work that we do, and those people who join in hackathon, they see these teams that you see here, Testoper projects. Otherwise, most of you will see, if you are only a learner and a continuous learner, you will see only this Testoper community channel, and you can collaborate before and after the program with the community. As an example, there are so many things that you may not be able to ask questions, and the presenter may not be able to answer them, or you might be working on your coding and you have some issues, and you want some clarifications and stuff like that. Then being in the Testoper collaboration platform can help you, because most of the volunteers are always online. They answer questions and things like that, right? So that's the first thing I wanted to say. I want to make sure if you wanted to be in Teams, please join that. And then the second thing is, our programs team will also post a WhatsApp link in the chat today. That is also for only those people who join our programs. The WhatsApp group is not for normal communication, but it's a group where if there is any emergency, change in programs and things like that, or if there is any requirement for volunteers, those kind of things we normally post in that close to WhatsApp channel. Okay, so the WhatsApp link also will be posted in the chat screen, so you can join the WhatsApp if you are interested. So the last thing that I wanted to kind of quickly touch bases with you guys is, what is Testoper, right? So this is the Testoper framework as such at a very high level. We mainly focus on people who, one or other way, involved in various designations, anything to do with developer, tester, or operations experts. Operations experts meaning monitoring, troubleshooting, database administrators, and things like that, right? Cloud, platform, infrastructure, Azure, and so on. So we basically focus on the people belong to these three categories, and we help them to enable creative talent. So what does it actually mean is, we help them from various different angles. We help them to improve the technical skills, such as coding, understanding tools, and frameworks, management skills, cognitive ability, personal qualities, and using all these different skills that you learn working on the live projects, where we can provide you the Canadian Experience Certificate, by which you can develop your knowledge and put all these skills and abilities and qualities that you have into a knowledge, right? So that's what we focus on. We focus on people to enable creative talent, mainly on the intelligent digital technologies area. So when you look at intelligent digital technologies area, there's two parts to it. One is the actual technology, such as blockchain, 5G, VR, AI, and things like that. Today is our AI program. And the second part to that is the architecture and the interfaces that you would use to implement those technologies, like cloud, RPAs, digital twins, cybersecurity that basically cut across all these different technologies, right? So that's something that we focus on. So by focusing these things, what we do is we enable the people to become a future workforce. So they can work in different industries, they work in different business operations, mainly focused on research and development and product management and the customer solutions, right? Help building the customer solutions, whether it is a product, platform, services, and so on. So as a nutshell, what we focus is what you see here. We focus on people, help them to enable creative talent on digital intelligent technology solutions so they can become a future workforce. If you don't know what is future workforce is, it's a mindset of an individual who can actually develop himself, his mindset to continuously learn. So at any given point of time, he has opportunities, but not in a place where he's not able to get a job, right? So the future workforce definition means that. So if you wrap up all these, everything, it's pretty straightforward to understand what is the vision of Testoper. The vision of Testoper is we empower every person to become a part of tech ecosystem future workforce. And our mission is, how do we do that is by enabling the creative talent to deliver and operate intelligent technology solutions through continuous learning. That's what the mindset that I was talking about, to help you with your career, intrapreneurship, and entrepreneurship aspirations, right? So that's our key focus of Testoper community. And it is a non-profit community. For those who do not know, non-profit meaning it is not run for profit. We totally rely on donations and sponsors, and we have to spend that money back as per the law to serve the people and give back selflessly. That's what we do. And most of the volunteers join us, have the intention to really help others, help them to grow and become successful in the career. Hopefully that gave a good picture about Testoper community to you all and what we are. We kindly request you to spread this news to your friends, colleagues, and your companies to help us in the form of attendance, donations, sponsorship, so we all can grow together, learn together, and become future workforce to sustain in this market, dynamic market that keeps changing. With that, I will hand over it to Shad, and Shad would be our presenter, and Harsha will jointly present together with Shad, and very best wishes from me to learn and continuously learn to become a future workforce in the area of artificial intelligence. All the very best. Shad, over to you.
Thanks, Kader. I'm going to start by sharing my screen. Can everyone see the screen?
Yes.
Great. So welcome everyone to the Artificial Intelligence with Python course presented by Testoper. My name is Saad. I'm going to be presenting alongside Harsha. I'm a data scientist based here in Toronto. I've worked in this field for a number of years, and I've been with Testoper for a few months. Before this, I helped with the Python course as well. Harsha, would you like to give a brief introduction about yourself?
Yeah, sure, sir. Thanks. Am I audible?
Yeah, you are.
Okay. Hello, everyone. I'm Harsha. I'm machine learning enthusiast. I have around 19 years of IT experience in various technologies, and I've been learning machine learning concepts, applying them at work. I would like to share what my learning is, and teaching people is something which interests me, and something not so easy as machine learning. It would be very interesting to interact with you and ensure that the knowledge is transferred. Thank you.
Great, thanks. So before we start, let me go over the objectives of what we want with this course. This is a very extensive field, and most practitioners here have spent a number of years in it. What we want to do is we want to give people an idea of what the important theoretical concepts are, what are the tools, how to get started with the technology in the field, and we also want to provide everyone a sort of pathway where they can continue to grow their skills and continue to improve. So this session is going to be broken down into I would say about half of it is going to be very theoretical and half of it will be practical, where we'll be actually playing around with code, playing around with data sets, and seeing real world problems being solved using AI. So the IDEs that we'll be using for this course will be Spider and Jupyter Notebook. What we would highly recommend is that everyone in this course download the Anaconda distribution. It includes the IDs that I mentioned and a few more, and it also manages all the data science AI packages for you as well. In addition, if we're all on the same page later on in the course, we won't have any issues with incompatibility and everything like that. Today's session is more about theory. So it would be a good idea to go to this link that I posted, start the download and install it while you are listening in to the theory. And I'm speaking this from experience because again, a lot of times what happens is later on we're in the code, we're doing some work, and someone doesn't have their environment set up, and then there are issues that we need to resolve, and that waste time. So if you could all go to this link right now, if you don't have the Anaconda distribution, and download it, it's completely free. That would be great. I'll give you guys 2-3 minutes to start the download if you don't have the tools.
And if you have any issues, you can always ask questions in the chat. And
Yeah.
You can always collaborate with Chad after the program. All volunteers are online, so we can help you with any technical problems that you face in the installation, and even in the coding and logics and stuff like that.
Yeah. If you have any issues with the installation right now, please write about it in the chat, and Harsha can, I'm sure, guide you through the solution. Right, let's get started. So, we hear the words AI, ML all the time. What is that? In its simplest terms, I would say the machine learning is, the process of telling a machine to do something, learn from the result, and then constantly improve. And you're going to keep doing that until you reach some sort of marker or accuracy. And artificial intelligence can be understood as a way of you using machine learning to solve a real world problem, right? So in the image, you can see that we're using a algorithm to detect objects. It's an object detection algorithm in an image or a video. So that's an example of AI, using machine learning to reach some sort of objective. And obviously, these tools are very powerful. They're used to solve some of the most challenging problems. The output of machine learning models can be in the form of a classifier. A classifier is understood as, for example, if you can see that that's a car over there, right? You want the computer to tell you if that's a car or not. So it's going to give you a number between, let's say, 1 or 0. 1 being it's a car, 0 being it's not a car. So that's what a classifier is. A regressor is a relationship between variables. And a cluster is, you put something in a group, in different groups, and then individual groups would be clusters. Again, we'll learn more about this as we go along. There are 3 primary kinds of ML algorithms. We have supervised learning, unsupervised learning, and reinforcement learning. The primary difference here between supervised and unsupervised learning is the kind of data that you're dealing with. With supervised learning, what you have usually is very well labeled data. What does labeling mean? So let's say I want to create a ML algorithm where I want to detect whether or not a dog exists in one picture. If I'm able to provide pictures where I know a dog exists and I can label those pictures as, say, positive, that's an example of data being labeled. Important algorithms in supervised learning are logistic regression, linear regression. In fact, Harsha will go over linear regression in this course, decision tree, and so forth. In most cases, when we have labeled data, we want to do supervised learning. We don't want to go to unsupervised learning because unsupervised learning has another set of complexities that we wouldn't want to deal with if the data is well labeled. So when do we use unsupervised learning? So A lot of times we have data where we can't really make any sense out of it. It's not labeled, and we want to use machine learning to find hidden classes or trends in the data. And that's when we would go towards unsupervised learning. An example of that is k-means clustering, which we might also cover in this course. A lot of times when people hear about machine learning, the first thing to think about actually is reinforcement learning. Reinforcement learning is when you provide some sort of function to a computer. That could be a reward function, which you want the computer to maximize, or it could be another function that you want the computer to minimize. And you give a lot of sort of knobs to the computer to tweak. And what the machine is going to do is it's going to try and try again to find the optimal answer to the function. So if you want to if you have a reward function, it's going to try to maximize that reward function. A very good example of this actually is Amazon recently held a competition, and it was like a game where you had to get a car to drive around a racetrack. And so that's an example of reinforcement learning where they had a reward function, right? So the further the car got, the higher the reward. So what they showed, and this was a competition that anyone could participate in, is that an optimal algorithm, if you trained it for long enough, it was able to drive a car at a very high speed around the racetrack, right? And they trained it for many hours, the winners of this competition. So that's an example of reinforcement learning. So let's go over deep learning. So we hear deep learning a lot. So it's important to understand where it fits in, artificial intelligence and machine learning. And it should be best understood as a subset of machine learning, and machine learning should be understood as a subset of AI. So for deep learning, you need usually a very, very high, very, very large data set. And you put that through what's called a neural network, and that neural network contains many layers. Those layers have nodes. As the data goes through those nodes, those nodes give different signals about the data. And then those signals are aggregated to produce some kind of result. Now, the vast majority of the deep learning that we're going to encounter in this course will be pre-built deep learning models, right? Organizations such as Google, OpenAI, they have very large data sets. So when they make a deep learning solution, it's usually much more accurate than something that we can make on our own. And those deep learning algorithms are available for, in most cases, open source for everyone to use. So this slide shows some of the different use cases for AI. You have stuff like computer vision, which we've all seen, audio processing, natural language processing, which is something that we're going to cover in this course. Understanding speech, and again, data visualization and recommender systems as well, which both of them are very important. We're going to learn a bit about linear regression right now. So this is an example of a supervised machine learning algorithm. Harsha, would you like to take the screen right now to talk about linear regression?
You want me to do it now, or because I will get into details of the computation, those things. You want me to start with it now?
Yeah, sure.
Okay, I'll get it started.
And just to note, if you don't have Anaconda distribution, this is a great time to try to download it, and we can resolve any issues that you might have with the download as well. You should have some screen like this open to you. This is what the navigator looks like, and these are the two IDEs. So
you're not sharing, Sumant.
Sorry?
You're not sharing.
Oh, okay, sure. Sorry about that. Yeah, so this is what the Anaconda Navigator looks like. This is the Jupyter Notebook, and this is Spider. These are the two IDEs that we'll be using for this course. So this is a great time to download this to make sure that if you have any issues, we can resolve them on the spot.
Let me know once you're able to see my screen.
Yeah, we are.
Okay. Okay. So as Saad mentioned, we look at the first machine learning algorithm, which is a linear regression. It is a supervised learning algorithm. It's one of the simplest. That's the reason we are starting with this. So what it tries to do is you have a set of data. It's a supervised learning. So you have predefined behaviors already there between the dependent variable and the independent variable. I'll introduce what these things mean. And since you already have the relationship between the dependent and the independent variable, we use the existing relationship to build a model. And using the model, we predict how the behavior is going to be when we have an unknown input. A lot of mathematical terms, so I'll slightly get into the details. So before we get into linear regression, how familiar are you with high school geometry?
What was that, Harsha? That was long time ago, man.
Okay, so
Right.
you know what a linear equation is, right?
No real point in asking. Just explain it.
Okay, fine. I just wanted to gauge, like, it shouldn't be very boring, right? So just wanted to check that. Okay, so you would have heard of this equation y is equal to mx plus c. I'll also remind you. So if you look at a graph, which we would have, started when we were in high school, you have the x variable and you have the y variable. And if you have a linear relationship between these two variables, you express y as y is equal to mx plus c. There are different ways of expressing this, but for this session, I'll take the equation y is equal to mx plus c. So what is m? What is c? M is the slope of the line and c is the constant at which it cuts the axis. So what we are trying to do is in machine learning, you have data points. You have x, you have y. I mentioned in my introduction dependent and independent variable. In this case, the independent variable is the x, the input parameters which we have, and the dependent variable is y, the value which we are trying to compute. So what we try to do is given a set of data x and y, we try to find a linear equation for this data. That is arrive at y is equal to mx plus c in such a way that it gives you minimum error. When I say error, I'll explain that. Error is defined as, the difference between the actual value and what the model is predicting. You try to keep the error at a minimal level and you define a linear equation. Using this linear equation, when you have new values of x coming in, you try to find the values of y. So this is linear regression in simple form. It had a lot of mathematical terms. So are you guys with me or do you want me to explain it again?
One thing that might help is to provide a real world-ish example for the axes, for the labels, the relationship between these two, why the relationship between these two variables is interesting.
OK, fine. So that's a good suggestion. I had an Excel sheet where I had built this out, but I'll also give you a real world example. I kept it at x and y because this is being used in equations. We have like the normal, if you look at, I'll take a typical example which we would get in any machine learning course. So if you look at cost of a house, that would depend on the square feet area of the house. You have like values like say 1,000 square feet is 500,000, 1,500 square feet is say 600, sorry, 600,000, 1,750 is say 650,000. If you have such data, in this case, the square feet value becomes X. That is, we know that there is a relationship between the price of the house and the square feet value. And there could be a linear relationship which we'll model and find out. There could be a linear relationship which we are trying to fit it into linear regression. This is one example which I have taken. The price of the house need not only depend on the square feet. It could have multiple parameters affecting the price of the house. Those are all those become additional independent variables. What I mean by additional independent variables, x1, x2, x3. Those are more complex forms of a regression, what we would call as multivariate regression. So for simplicity's sake, we'll start with univariate regression, which is the output variable, that is the price of the house in this case, is dependent only on the square feet of the house, that is x. So we can take that as an example, x and y, and work out a linear regression. That's a real world example which we can look at. Just to explain the linear regression concept a bit more, I've taken a simpler example here, x and y. I've taken values 0, 1, 2, 3, 4 till 8. And y values, I've assumed in this case, for simplicity's sake, I have taken y value to be the same as x. So the equation is y is equal to x. That is the equation. So when you apply it in mx plus c, what happens is m becomes 1 and c becomes 0. What we will do now is what the model tries to do. So you have this data with you. You have x and y with you currently. For now, assume that you don't have this information. The model doesn't have this information. What it tries to do is fit a straight line in such a way that for any new value of x, you get the correct value of y. That is what we are trying to do. We are trying to predict what the value of y will be based on x as the input. Are you with me on this?
So
This
far,
is a
so
nice.
Yeah,
This is a nice example.
sure.
Evocative. Good.
Fine. Right. So what the model does is it assumes a value of m and x, just initial value, and it tries to find whether that is the line which would fit this data. So what I have done here is it starts with first, once again, to explain, I'll make c as 0 and I'll assume m to be 0.25. So the equation is y is equal to 0.25x. With this as the assumption, if I calculate y is equal to mx, these are the values I get for each value of x. So this is the calculated value by the model, assuming m to be 0.25. Are you with me on this?
yeah.
Yeah.
Okay. Yes. Now, assuming m to be 0.25, what is the error we are getting? And as I mentioned, the error is the difference between the computed value and the actual value. For this data, we have the actual value. So what happens is the error here, you can see the error coming in here, the difference between the computed value and the actual value. What the model tries to do is change the value of m and x in such a way that the error becomes as low as possible. And for doing this, the model just doesn't take the error alone. It takes the sum of the squared errors. Why is it squared? Because the error could be positive or negative. So we can't just like that add, right? It takes the sum of the squared errors and finds the average or half the average. Because when you minimize half the average of this value, you get like you minimize the total value too. Why half is taken? Because it will be it will be useful for mathematical computation later. So I'll repeat this point. What it does is it computes the error, takes the squared of that error, okay, takes all the values, sum of all the squared error values, okay, takes the average value of that. So what it does is this value what you get is called as the cost function. I'll explain why it is called cost function. This is the value you get, which is going to talk about the error when you have chosen m value to be 0.25 and constant value to be 0. What the model does is it tries with one such value. OK, it sees that the error is there. So what it does is it changes the value of m. It tries this out. it changes to 0.5 and it sees that error is decreasing. So same way, it just keeps moving till it reaches a point where it finds the error to be minimal. Whatever I'm doing here is what a linear regression model does. If I reach 1, then the value becomes the error value becomes 0. So till it reaches this point or a very minimal error value, it keeps changing the values of M and C so that it can find the line of best fit for this given data. I will explain the whole thing again. This is supervised learning, which means we have the output variable values for a set of known input variable values. Based on this, we are building a model so that when we get a new input, for example, if you get x is equal to 9, we'll try to find out, we don't have the y value. We try to find out what the y value is. So you're trying to build an equation for that in simple terms. So the way it does it is it takes these values. It's a linear regression model. So we know that the equation is y is equal to mx plus c. It starts with a set of values for m and c, finds the error squared and average error squared value. And this is the indicator, the cost value, the cost function is the indicator. It changes the values of m and c. Here I've kept c to be 0, a constant, but it changes the value of m and c in such a way that this value becomes as minimal as possible. I told you it's called cost function. I'll explain why it is called cost function, because when you're trying to devise a model, what happens is that if you have a difference between the actual value and the predicted value by the model, in some ways, if you see, that is the cost you're paying for the model not being accurate. That is the reason it is called cost function. Are you with me on this?
Very well, very much. Please proceed.
OK, so all that a linear regression model does is this in simple terms. Now I'll go back to slides. So what the model does is what I've written here. The straight line is chosen in such a way that the cost is minimal. OK, the cost is actually the sum of mean squared errors between the predicted and the actual value. If you look at this graph, this is the data. These are the data points. Say the x-axis is here, the y-axis is here. Say this will be the line of best fit. So what it does is it if for this value of x, this is the predicted value of y, but say for this value of x 0, this is the predicted value as per the model, but the actual value is here. So there is an error. So it finds the error for all the data points and then it selects a line in such a way that you have the line of best fit so that the sum of mean squared errors is minimal. With this, it will find out y is equal to mx plus c. You have the model built. When you have the model built, any new value of x you get, you apply it in the equation, you will get the predicted output. This is machine learning with linear regression. Is this clear?
Harsha, one question.
Yes.
When you in the Excel sheet, you are sort of manually changing the value of m.
Yes.
Almost arbitrarily or at a fixed rate. You increment it by 0.25 every time.
Yes.
But isn't it the case that the way you vary the value is actually dependent on the cost?
A good question. So the way it does it is it's in the next slide actually.
Okay.
So you have the way the new parameter value is actually there is old parameter value minus the learning rate into partial differential. But I thought instead of introducing gradient descent straight away, I thought we'll talk about the concept behind, and that's the reason I showed it manually.
Okay. Sorry. Thank you.
Any other question? If you don't have questions, I'll assume that it's very well understood.
Yeah, you can also write the questions in the chat and I'll answer them.
Okay, I'll take silence as no questions, which means I'm assuming that it's understood. I know it might take some time to understand it fully, but if you want me to repeat something, let me know. I'll repeat.
Can I add that if you have a question and ask it, you are doing a wonderful favor for everybody else who is too shy to ask. So I would encourage, if you have a question, to bring it out.
I would second that, because if you have the question in your mind, it's better to get it clarified here. It'll go off and it'll help you understand the next few steps in a better way.
Well, I must say that your explanation was crystal clear, Harsha. No questions.
Okay. Okay. Thanks for that. Okay. So now that we have seen the linear regression part, we'll also look at how the model works with the gradient descent. I'll come to that. I'll explain what is gradient descent. Okay. And this is a meme which we always find, anyone who's interested in machine learning, you need to cross mathematics to get there. Not only mathematics, there are many things, statistics, and few other things which are blockers, but we are there to help. Don't worry about that. Okay. So with that, to reach the minimum cost, we have a method called as gradient descent. Okay, I have attended Andrew Ng's courses. He's recognized as the machine learning guru. He has a way of denoting few things. For example, the m value which I spoke about, he denotes it with theta1. C value is theta0, and j is the cost function which I spoke about. So if you look at that, here the graph on the left hand side is with the example which I had seen, where we had assumed theta 0 to be, or C value to be 0. And we tried to play around with M value or the theta1 value. What he has seen, what he has shown here is how the cost function varies when you play with theta values and what would be the gradient descent value. So what happens is, to reach the minimum cost, we need to keep changing the M value or the theta1 value. I'll slowly move to theta, and till it becomes familiar, I'll keep mentioning M also. So we need to change the M value or the theta1 value. OK, so how do you change that? You start with a value, with an initial value, and then the next value, what you need to change, how do you determine that, is the old parameter value. When I say parameter, I'm referring to theta1. OK, the old parameter value minus the learning rate. This is a new term which I'm introducing. There's a learning rate into partial differential of cost function with respect to the parameter. Don't get worried about this term. All that it says is, if you plot the cost function with against theta as x and y, it's only talking about the slope of the cost function with respect to theta. That is the explanation for this. In simple terms, you're finding the gradient. This is the reason I asked how familiar are you with high school mathematics? Are you with me on this, or do you want me to explain this a bit more?
It would be good if you show this in Excel sheet. Excel sheet was good, actually.
OK, fine. So what happens is, see here, if you see here, I'll change M value to be 0.25 itself. OK, if you see here, this is the error squared, right? This is error squared for each value which we have taken. OK, I'll also do something like this. For 0.25, the cost is 6.375. So what I'll do is, I'll have 1 minute. I'll just move this graph out. Actually, I don't have the graph which is shown in the PowerPoint setup here, so I'll just set it up and you'll see how it's being done. OK, so cost. So what it does is, it checks, it takes a value of M is equal to 0.25, some initial value. OK, then it takes a cost function which is 6.375. OK, and then I'll explain how the model does, but now I'm doing it manually. OK,
One thing that would really help would be to visualize the data points, the actual data points relative to the line. So we could see, as in the diagram that you've got on the initial linear regression slide.
Yes.
The data points as distinct from the slope of the cost function, or of the model, would be really super helpful.
Okay, 1 minute. I'll try to add that. It's not matching, right? 1 minute.
So Harsha, maybe I put you in trouble. Maybe you wanted to prepare this for the next session to explain.
No, it's not that way, but what he's asking is how does the actual value look with respect to the line? Actually, I have the line here and I have the actual values here. So I'm trying to combine both these charts. That's what I'm trying to do. It's not related to the question which you had asked.
Okay.
Okay, I'll come to that point. For now, I'll show it in two different charts. I'll explain this. I'll try to show this graph in Excel sheet and then I'll move to the other point. Okay, 1 minute. Coming back to the graph we were trying to build. What the model does is it takes an M value, finds the cost for that, and then it tries with another M value and then tries to find the cost. So here the cost is.
So one way, while you're doing this, a friend of mine who is an AI programmer basically explained that in this case, what the machine learning is doing is it's throwing spaghetti against the wall and seeing what sticks best.
Yeah.
It's just trying a whole bunch of different values for M and seeing if it can reduce that total variance.
I think Harsha 0.25, 1.25 value was 0.708. I think you had another extra zero.
Oh yeah, right. Thank you. No wonder the parabola is looking different. OK, so Kader, what you were asking for, right? What the model does, see, it changes the M values and then it finds the cost function. And we know how the cost function is computed. It's an average of the mean squared. It's the average of the sum of the squared values for individual inputs. And then what it does is it gets this graph. So what I was trying to explain is when you have the first value here, OK, which we took as 0.25, say it takes a value, and how does it find the next value is what I was trying to explain. For that, it uses a formula. What it does is this is the cost function. OK, it takes the old value, that is 0.25, the cost function old value, which will be 6.37. Sorry, not the cost function, I confused. It takes the old value of the parameter 0.25 and it subtracts a particular quantity. How it computes that quantity is you have something called as learning rate, which is called as alpha. It takes the learning rate. It's a constant. You can define it for a model. You define that and then it takes the partial differential of the cost function with respect to this parameter. That is in this case, M. It subtracts that quantity and arrives at the next value. Say, for example, if the slope is, say, here the slope will be, say, if it is 1 or something like that. And if you have a learning rate of 0.5. So what it does is it takes 0.25 minus 0.5 into 1. So it will go to minus 0.25. It will try these values. It will here I took an example of a slope, but the learning rate and the slope will be properly computed by the model. So this is how it arrives at the next value of m. It keeps trying this till it finds a minima, that is this point where the cost is actually 0. Here, if you see, the cost is 0 or as minimal as possible. Sometimes the cost will not be 0. So what it does is it tries to find the minimal point that it has to reach for the model to give you the best prediction possible.
Got it. Got it. Clear. Thanks, Harsha.
Okay.
Harsha, before you continue, there is one question. It is is gradient descent related to the slope delta method?
I need to check that. I'm not sure what slope delta method is. I'm
Yeah,
familiar
same,
with
that's
gradient
yeah,
descent.
It's
yeah.
in various Monte Carlo methods that are used for curve fitting. Slope delta is exactly this. Keeps on calculating the delta of the slope between different iterations. And as the slope goes on reducing, that's the direction in which the solution iterations should be moving towards.
Okay. Okay. Then it should be the same.
Okay.
Okay. And what we should also remember is when we are having when we are determining the learning rate, if you're coding for that, the model actually with Scikit, everything, you don't have to worry about this. But if you're doing it, if you're writing the Python code for doing this itself, the gradient descent itself, then you should ensure that there's optimum learning rate. Say if you have a big learning rate, what it will do is from this point, it will jump to another one and it will keep oscillating, say from this point to this, and it will keep moving. And small learning rate, it will take too many iterations for it to reach the minima which we are looking at. So what we need to ensure is there's an optimal learning rate that is determined for a model. That is something we need to take care of. So this was the concept behind how a linear regression model unfolds. You take the initial set of values x and y, tries to fit the line for that set of values so that when you get new input, you can determine what the output would be. While doing that, I've also explained how it actually determines the line of best fit by varying the slope or the parameters, the slope and the constant. And for that, it uses a technique called gradient descent. I've explained that. The learning rate is also explained. With all these things, you have the model which is going to be built so that when you have an input, new input coming in, you can have the predicted output. Now, the best part. We learned all these things. It has got a mathematical significance. What is the concept behind that? Linear regression, we have seen that. If you get to the actual doing part, you don't have to worry about all these things because you have Python libraries which take care of all these things.
Great,
You want
great.
to check that?
Yeah.
Great. Thanks, Harsha.
Yeah.
Harsha and Shad, in case I know that this current session, we have it for next 6 weeks, right?
Yeah.
Ends on October 24th, right? And the last program that we had on this year is cancelled, right? So if required to extend this session for another 2-3 weeks, we can. It looks like there's a lot of interest in this session. So just don't worry about the time and don't hurry up. Take your time to do. Considering this is going to be the Saturday track last session for the year, you have additional weeks if you need to. Okay.
Great, thanks.
Yeah, I endorse what Kader is saying. It's even if we go slow and we learn thoroughly, it's better.
Great.
Okay.
Harsha, before you show Jupyter notebooks, can I just give a quick introduction to Anaconda Navigator if people have downloaded it, so they know how to do package installations and open the IDs?
Okay.
Good idea. Maybe we can do that and close today's session and continue next week.
Yeah. So one request, Kader, I'll just show the linear regression code. What is there, so that like
Okay.
I know
Yeah.
there was a lot of
Okay. Yeah.
mathematical explanation, so I don't want them to go with the idea that, oh, it's going to be very complex. It's a lot simple than what I had explained.
Please go ahead. Please go ahead. Yeah.
So I'll, after Saad is done with Anaconda distribution installation, I'll come back to this. It will only take 5 minutes. I'm not going to talk a lot. This
You
code,
know,
we'll look at it in detail later.
Why don't you close this and then Chad can go to Anaconda installation.
Okay, that's a
Yeah, just continue with this and I'll take it over once you're done with this example.
Okay, so whatever we saw in the slides, that was the conceptual understanding between behind linear regression. So how we are going to do it in the code is what we are going to see. So there are libraries which take care of everything. So here you import some of the Python libraries. You have NumPy, you have Matplotlib for the charting portion, and you have Pandas for the data analysis. So these libraries, like, they help you. Apart from this, you also have the scikit-learn, which will help you build a model. So I've taken this data, which is years of experience and salary. So like the example which one of the participants asked. So you have, like, depending on the years of experience, this is the salary which I've taken. These are random numbers. Please don't attach any significance to this. So you have years of experience till 10.5 and you have salary. Say here you don't have value for, say, 4.7. So with this, you build a model, and when you have someone who's going to come with 4.7 years of experience, what the salary will be is what the model is going to predict. Are you with me on this?
Yeah.
Okay, fine. So with this, this is the data which has been taken. It's very simple. Take the data set. See, this line is, you have the libraries. Instead of writing NumPy everywhere, you just have a short form here. So you use that. So for pandas, it's PD. So you have a read CSV function which reads the function. And what you do here is you assign the X variable and Y variable. This is the range. This is called as index location, which pandas provides when you have the data set. So what you do is you determine which is X value. Here, this line practically says this first column is the X value and the second column is Y value. That is what it does. And then what you do is when you build a model, what you do is you have, like, the data here. OK, you don't want to use all the data to build your model. What you try to do is you use, say, for example, 80% of the data to build your model and try to test it with the other 20% that is left out. So this 80% and 20% are called as train and test data. So you have, like, the train data with which you're going to build the model, and using that model, you go to the test data and check whether the model is working fine or not. So you need to split the data. When you get the complete data, you need to split the data. So that is what is done here. You split the data into train and test. OK, you have the details here. So you have the size mentioned here. Here it's like, 33% is taken as test size. And then what you do is you call the regressor, with which, like, it just builds the model. You just give the train data, you call this, and with this your linear regression model is built. OK, once the model is built, what you do is you predict. So I mentioned that you have the test data and the train data split. So with the X values for the test data, you try to predict what the Y value is. Please remember, for this test data, you also have the actual Y value which is with you. So you know how the model is performing. You can compare it. It's like, what you do as unit testing when you're developing, right? You write a test plan where you have the expected behavior and you write the code and see whether your code is giving the same thing, right? It's similar to that. So what you do is you find the prediction from the model, and then you just the rest of the code is just showing how the model is built and just visualizing the whole thing. So if you look at the training set results, this is what one of the participants had asked, right? So you have the actual values here and the line which has been built by the model. So the linear regression line. So this is from the training data, that is in this case 66% which we had taken. And what it does is, and the second part is with the same model, what we have done is we have supplied the inputs for the test data. That is the other 33%. We have just given the input and we are finding out what the model is predicting. In this case, you have the, and we, for this set, we also have the actual values. So you can see what is the difference between the actual values and what the model is predicting here. Say here it's exactly matching. Here there's small difference. Many cases it's exactly matching. Here there are small differences. So this is what you will have from the model.
Great, thanks, Harsha.
Yeah.
Just give me 5 minutes to go over Anaconda Navigator and the next steps for our next session.
Okay, I'll stop presenting.
Thank you very much. Like I said, Harsha and Shad, we can have extended sessions if required. I just want to ask this question. There's a person who joined with the phone number 437-971-5153. Can you please identify? And also another person who's joined with AIML.events.
Hey, this is Madan. No, that is my number. For some reason, it is showing me with my mobile number. But if you get into the chart, you will have my name as Madan Kishore Tamarapalli.
Okay,
This is the first time I'm logging into Teams, so I'll just fix it for the next week. I'm sorry about the problem.
Thank you very much. You know, it's okay. Just wanted to identify the names by names, right? That's good. So could someone identify who is AIML.events person? Hello? Irene. Okay, so next time, please join as Irene. I would appreciate it. Thanks a lot. Please go ahead.
Sad, just before you start, if you have any questions, see if you feel that it's a bit complex or something like that, don't feel worried because all of us have gone through that. If you have any questions, we are there to help. If you want to have, there are study group sessions which will be organized for this track also, so we can discuss few things there. So please don't hesitate to ask questions. Ensure that you have a good understanding. If you have a good understanding of linear regression, then it can, you can get into other areas easily. So it will be the same template which we'll follow. So please let us know if you have questions. Thank you.
That's a good thing. Hey, for those who don't know study group, you guys remember when we were young, we just get together with friends and we sit and study. For those who study and for those who don't study, whatever. But that's the study group, right? So likewise, obviously, right now we are going through the COVID challenges. We used to have this in-person study groups, but now what we are doing is we are doing this virtual study group. So people come together, they sit together, they learn. There's multiple study group happens, and a lot of people continuously try to learn from that particular study group channel that we have in Teams. That's what study group means, what Harsha explained. And Harsha and Shad are in the team, so they continuously help you guys whenever you have questions or wherever that you whatever you face problems, they're there to help you guys. Okay, Shad, over to you.
Great, thanks. So you all should have downloaded Anaconda by now, and you should be able to access this navigation page. Over here, the two IDs that we'll be using will be Jupyter Notebook and Spider. You're free to use either of the two. The good thing about Anaconda is that it keeps track of all the packages related to your work data science. So you can, for example, go on environments here, pandas, and you can see that I have pandas installed. Another way to check is you have the Anaconda prompt. You can just search for it over here. If you're using Windows, in a Mac, there's probably some other way to search. And then you can just check if you have a package installed. If you want to do an installation, you'll have to do pip install and then the name of the package. Most packages that we'll be using will probably already come installed with the Anaconda distribution.
Shad, sorry, can you increase the font? There was someone request on that terminal window.
It's just pip show, so I don't know how to increase the font here.
Okay.
It's just the only command is pip and then space show, or
right
pip
click
install.
Right click on your caption bar up at the top there where it says Anaconda prompt. Right click on that.
Oh, okay.
And then size. Sorry, properties. Pardon me. And there you get a chance to show the fonts. There, a second tab at the top. There you are.
Oh, thanks.
Lovely.
Great. So yeah, it's a pip show or pip install, and then the name of the package. Again, this session is being recorded, so you can come back and see the exact commands as well. Now, for next class, we're going to be playing around with the Boston housing dataset. Let me open the description of this dataset. So this is a very famous dataset. It's used for a lot of work. You can find a lot of work done on it on GitHub, and we'll be doing some data science on this as well. What it has is it has housing prices, and then per area it has these stats, right? So per capita crime, proportion of non-retail space in that town, average numbers of the rooms in the house, and so forth. And usually you can use this to try to figure out what the price of the house is going to be. I want to just show you guys how you can access this data set. So this is Spider. This data set is already provided with scikit-learn, so you can access it with this command from scikit-learn.datasets import load Boston. You get NumPy, you get pandas, and then this is the command to access the data set. And then you can use this command to convert the NumPy objects into a pandas data frame. So this is what the data set looks like right now. What I would like you guys to do for our next session is to download or access this data set and just play around with it, see what you can find. And we'll be doing some interesting things with it in the next session. I will post this link to the chat so you can read up on what the variables and everything mean.
That's really good, Shad. It's important to let the attendees know to prepare themselves before coming to the next session. So there's a lot of good active participation. Thanks a lot.
Yeah, I'll just post this link here to the data set. And as for the code, this session is recorded, so you can just access it later and get the exact code as I wrote it.
Perfect.
And Saj, will it help if I copy that Jupyter notebook details to chat or somewhere?
Yeah. Is it a cloud notebook?
No.
Oh, okay. You can probably upload the notebook as well on the files.
Yeah, I'll do that.
In the Codeathon track, right, to create a folder, there's already a folder structure, Harsha, you know, right, how to. Yeah, please post it. And those who have trouble to get all these things done and be ready before the next session, please ask questions. There is a help for you before you coming into the next session to have you all cleared out. All right.
Great.
Okay, sounds good. You all have a wonderful
I have
weekend.
one question, please.
Yeah, go ahead.
So Harsha showed in Jupyter Notebook, and the later the screen for IDE seems Spider. So where are we going to focus more on, Jupyter or Spider?
So you can use let me take that. You can use either of the two. Spider or Jupyter Notebook are both included with the Anaconda distribution. Whatever you're comfortable with, it shouldn't make a difference, right? The code will be the same.
Yep, thank you.
Great. Should we close the session then, Kader?
Yes, Shad, if you guys are done with it, let's close the session. Thanks for everyone joining. Please do refer to your friends, colleagues, loved ones to come and take benefit of this sessions. Thanks a lot again to Shad and her taking time and volunteering to help every one of us to learn and continuously. Thanks a lot. With that, let's close the call. Anyone else have any final
someone
question?
had a question. Someone had a question.
Yeah, thank you very much for this session. It's really been enlightening. However, how do we get details as to subsequent sessions? Is there any official page, say on WhatsApp or some other social media platform, where we get details on subsequent sessions?
Yeah, so you go to the Eventbrite and then search for Testoper. You would actually see all the sessions, right? Let me just quickly show you. So just go to the Eventbrite and then you would see all these sessions. So right now, there's a couple of sessions that are ongoing. One is Robot Framework. This happens on Wednesday. This is the test automation track. Wednesday 7 p.m. right? And the one that we are going through now is IA track, intelligent automation track, which is Saturday at 10:30 a.m. And this program is our last program for this particular track for this year. So we have been doing this every Saturday and every Wednesday. We have continuously sessions, 1 hour sessions since last 7-8 months. And most of the time, this is the right place for you to kind of get them and register for them and come for it. Okay, did that answer your question?
Yeah, thank you very much.
Thank you. Okay, all the very best. Have a nice weekend. I know this weekend, at least for those who are in Toronto, it's pretty cold. So anyways, we are staying home, so it won't make any much of a difference. But have a nice, wonderful weekend. I'll see some of you guys on Wednesday session and others on next Saturday session, continuation of this artificial intelligence with Python IA track. Take care. You all have a great day. Bye-bye.
Thank you.
Bye, everyone.
Bye, everyone.